mitochondria. So this picture is of the inner membrane of the mitochondria, which we call what? Do you remember? It's in your notes. Yeah, the cristae. So the mitochondria is the organelle where cellular respiration occurs only if oxygen is present, right? So this is where we get that really high amount of ATP, that 28 in the electron transport chain, right? That's the last step in cellular respiration if oxygen is present, which means if we're breathing well. So if you're on the treadmill or taking a long walk with your dog, you're in the electron transport chain, Krebs cycle, glycolysis. There's lots of oxygen to go into that mitochondria and serve those last two processes. So in order, when glucose enters the cell, what is the first process to break that glucose down? What is that first reaction called? Glycolysis. Glycolysis, and it takes place in the cytoplasm. And the reason it takes place in the cytoplasm, and I want you to write this down in your notes, the reason glycolysis takes place in the cytoplasm is because the enzymes for these processes, those three major steps, remember the activation, the cleavage, and the oxidation phases. You don't have to know the specific phases within glycolysis. I just want you to know glycolysis takes place in the cytoplasm because the enzymes for the reactions of glycolysis are found there. And when we're done with glycolysis, we have 2 ATP and 2 molecules of pyruvic acid, right? And oxygen is not required to break down that glucose into pyruvic acid and ATP. Then, if there is no oxygen present, what happens to the pyruvic acid? It goes into lactic acid, and that's the burn we feel in our muscles. And eventually, the lactic acid can be converted if we have a lot of oxygen present after the fact. Like when you get to the top of the stairs we talked about and you do heavy breathing, that's paying that oxygen debt, and we can convert that lactic acid and reverse these reactions all the way back to glucose if we need to. So typically though, we can breathe with a little bit of activity and add enough oxygen to continue this pyruvic acid to be converted to what? To enter the citric acid, or Krebs, we'll call it the Krebs cycle. Do you know what pyruvic acid is broken into? First thing is acetyl-coenzyme A. Acetyl-coenzyme A, after it enters the mitochondrion. So the pyruvic acid enters the mitochondrion, and we're in the fluid part. We're in the matrix. And why? Same answer. Why does the Krebs cycle occur in the matrix, the fluid part of the mitochondrion? Say it louder. Someone said it. Yeah, because the enzymes that are specific to the Krebs cycle are found there. Okay? And again, enzymes are proteins, right, which are driven by DNA, but we also have to bring amino acids into our diet to feed metabolism, right? So we talked about a healthy diet provides the enzymes, provides the amino acids, and the coenzymes, those B vitamins, vitamin B6, vitamin B12, that helps these reactions occur and gives us energy and makes us feel good. Poor diets cause low energy, inflammation, low mood, right? So we can fix that just by making better choices in what we eat. Okay, so that's the Krebs cycle. And the waste product of the Krebs cycle is what? CO2. Yeah, and it's easy to remember. Krebs starts with a K sound, and carbon dioxide starts with the same sound. So remember, carbon dioxide, Krebs. And at the end of the Krebs cycle, what do we end up with? We have these coenzymes that picked up hydrogens off of this sugar. As it works its way around, we end up with all these keto acids. As we remove hydrogen, NAD plus picks up that hydrogen and it's going to take it to the next step, which is the electron transport chain. So we have NADH and H plus, and we have FADH2, so they picked up hydrogens from these keto acids, these intermediates, and carbon dioxide. And a little bit of ATP. How many molecules of ATP at the end of the Krebs cycle? 2. This does require oxygen, but not directly. So does not directly require oxygen. Make a little note. I'm making your crossword puzzle really easy by adding these little notes. So does not use oxygen directly, but it does require oxygen. So just think, the mitochondrion requires oxygen to do its thing. We're in the fluid of the mitochondrion right now. If we don't have oxygen, we're stuck with glycolysis and lactic acid, and that's it. But if we have good breathing occurring, we don't have crappy lungs from COPD, we don't have someone in the middle of a seizure that's full contraction and not breathing well, we're going to enter into the mitochondrion. So if someone's in a full seizure, like some people can be seizing for 30 minutes. I know someone who had a child that was seizing for 30 minutes, and they were giving all the medicines to try to stop it, and they couldn't. So what was that child at risk for? When we're lactic acid, lactic acid, lactic acid, what is that going to do to blood pH? It's going to drop it, yeah, and that person's going to end up with acidosis. So we have to fix that with basic solutions, infusions, like sodium bicarbonate is a common thing we give. Anyway, so this is the Krebs cycle, and then this NADH plus and FADH2 move on to the electron transport chain, and they start, we can see here, they start dumping off hydrogen ion, and this is the matrix of the mitochondria. So it's not the outer wall, this is the outer wall. The matrix is the inner membrane. I'm sorry, the cristae, not the matrix, the cristae. This is the cristae of the mitochondrion, and they have these special proteins embedded in the cristae that help pump out these hydrogen ions that are released from NADH and H plus that were created in the Krebs cycle. So can you see how these two reactions are complementary? Then excess hydrogen combines with, here's the oxygen usage, so the electron transport chain uses oxygen directly. That combines with those excess hydrogen ions to make water. So what's the waste product of the electron transport chain? Water. Water, because we know in our breath is water vapor and CO2 as a result of metabolism. And then why do we want all these hydrogen ions outside the mitochondrial cristae? Because it serves as a fuel for the ATP synthase pump, right? And this ATP synthase pump fuels the reaction of adding a phosphate to ADP to make ATP. And we get lots of it, right? We can get up to 36 ATP in one glucose molecule, depending on the cell. Some cells are more metabolic than others, but we get lots of ATP with this reaction. But again, oxygen has to be present in order for this to occur. So that's a little refresher of, yes?
So are those, is ATP synthase, like, are they pumping the hydrogens out to the outside, or is it that just putting the, phosphate on it?
Right, that's the primary role of the synthase pump, is to phosphorylate ATP to make ADP to make ATP.
And how do all the hydrogens get on the inside part?
They diffuse through this special pump. This ATP synthase pump reacts with, this is a protein. And that's the, like I said, that's the beauty of taking an A&P class, is we were taking biochemistry, we'd be looking at all the chemical reactions with these proteins and how the hydrogens interact with them. But for our purposes, all we have to know is that this ATP synthase uses hydrogen as a fuel to drive the reaction of ADP to ATP. So it acts as an enzyme, a synthase pump. It's a protein that acts as an enzyme to fuel this reaction, but it needs hydrogen ion. Now we could analyze how that happens, but that's beyond the scope. That's more for like a graduate level biochemistry class. So for our purposes, just know that it's a fuel for the ATP synthase pump. And where do the hydrogens come from again? Yeah, from the NADH and H plus and FADH2 that were formed in the Krebs cycle. So then when they lose their hydrogens, what do they become? They become NAD plus and FAD, and that's convenient because that's what we need over here, and they just get loaded up again. So it's picking up the hydrogens in the Krebs, dumping in the electron transport chain, back to the Krebs, picking it up, dumping in. So these are really linked reactions, are they not, with the hydrogen ions? Okay. And we don't want excess hydrogen ion building up. So again, as long as we have plenty of oxygen, because if we have excess hydrogen ion, that's what the pH scale is based on. If we have excess hydrogen ion floating around in our fluids, body fluids, that's going to drop pH. So as long as we have oxygen present, that's going to bind up the excess hydrogen ion and form water. And water we know is neutral, right? And most of our body is water. So we form water as a result of metabolism. All right, so that's just a little review of that. Here's a little more information, kind of how this goes. You know, we have higher concentration of hydrogen ions on the outside of the inner membrane, less on the inside, so they diffuse by diffusion, but these are charged molecules, so they have to go through a protein to get through this lipid bilayer, right? Okay, so now we're going to move on to some bigger concepts that we can relate to, hopefully, a little more. So how much energy do we get? We have a glucose molecule with all the energy in these bonds. Every time we break a bond, we release energy. How much of that energy goes into making ATP? 38%. 38% of the energy in one molecule of glucose is used to make ATP. Where does the rest, where does 62% go? Body heat. Yep, lost as body heat. But it plays an important role, right? We need body heat. We need 98.6 degrees Fahrenheit to help our enzymes function. Enzymes are temperature dependent. So if we didn't have a 98.6 resting body temperature, or give or take a couple of degrees, right? Our enzymes wouldn't work. What happens to people with a really high fever? What happens to enzyme function at high temperatures? They actually speed up and break down. So what do people look like when they have really high fevers? Sweaty, flushed, lethargic. When the temperature is so high that it's affecting enzymes for brain function, people are really lethargic. And it's really important to watch that in children, because children are not very good at regulating their body temperature, and they can get really high fevers and go into seizures, right? We've seen seizures happen with really high temperatures, febrile seizures. So if we don't have enough body temperature, reactions slow down. And the good part about that is oxygen usage is less. So people that are having like heart attack or stroke, they have something that they do in the ER called induced hypothermia. Have you ever heard of what that is? Where they'll pack the core parts with ice, so in the groin and armpits and around the neck to cool the body down so there's less oxygen usage while they're trying to repair a blood clot or even doing certain surgeries. They lower body temperature so there's less of a damage to the brain. Okay. So this is a nice summary of what happens. So here's the mitochondrion. So we have glycolysis happening out here in the cytoplasm because that's where the enzymes are. We end up with 2 molecules of ATP and 2-pyruvic acid. And then remember 2 were used to activate the sugar. So it actually produces 4, but we had to activate it. So we end up with a net of 2. And then that pyruvic acid enters into the mitochondria, is converted to acetyl coenzyme A, which goes into the citric acid cycle, which produces carbon dioxide and 2 more ATP. And then that NADH plus, or NADH and H plus and the FADH2, which are produced in the citric acid cycle, continue on into the electron transport chain. And we end up with lots of ATP being produced, with a total of 30 to 36. Your textbook says, or this picture says 30, but it can be as high as 36. But you'll see the difference. I'm not going to mince hairs and have you decide between 30, 32, or 36. It's just anything greater than 28 is the result of the electron transport chain. And that's what fuels our activity. When things are going well, we are getting the oxygen we need and we don't feel short of breath. Okay, so this is a video you can watch on your own. I want to talk a little bit about angina. Angina is chest pain, pressure, or any discomfort related to poor blood flow, which means the heart muscle cells are not getting the oxygen they need, and there's an increase in lactic acid. And because of that increase in lactic acid, it causes that burning sensation or a pressure sensation. And sometimes that pain can move up the jaw, it can be behind the ear, and it moves down the left side of the arm because of the way the nerves are that serve the heart also have the same pathway to the side of the neck and down the left arm. So we always have to pay attention to people when they talk about pain. Like I went into a patient one time that came in for chest pain, and I said, how are you feeling? Any pain? No pain, just pressure. Oh, that's bad. We got to take care of that. So it's best to ask, are you having any chest discomfort? Because discomfort can be a number of different things. Or you even talk about jaw pain, teeth pain. So, and shortness of breath. That's another thing. I was running in just a fun run at UWL in November, and it was really cold, and we were running around the track as the final lap, and it was just really cold out. And I got to the end, and I had this burning sensation in my chest. And I'm like, oh my gosh, am I having a heart attack? Or are my lungs just fried from breathing in this really cold air? And I did a mental check. Am I short of breath right now? Because when we have lactic acid, that means there's not enough oxygen production. What does that tell the brain to do? It tells the brain to increase the rate of breathing and try to bring more oxygen in. So if you're having chest pain with no shortness of breath and you can walk around with no problem, that's not typically a sign of a heart attack then. That's more something musculoskeletal or maybe lung related, because we have patients that come in with that and it's not heart related. Okay, so that's called angina due to a blood clot. So now we're going to talk about, once we have this metabolism going on, we just assume that it's going on and we're always bringing in glucose, or if we don't have glucose, we're in starvation mode, how our body can use stores of either protein, fat, or glucose, stored glucose, to get energy and make ATP, because the goal is to keep this body going, and to keep this body going we need a steady supply of ATP. And we don't store very much ATP. We can always pull things from the body to make it when we need to. So we're going to start with the first process, which is making glycogen. So I want you to highlight the root word here so you focus on, you don't see it as one big word that is overwhelming. Just focus on the root word glycogen. And genesis means to make or create. So this is how we make glycogen. And then again in this word, I want you to highlight the word glycogen again. But here, lysis means to slice and dice or break down. So when we say glycogenolysis, lysis means we're breaking down glycogen. So is the body in a resting or working state when we're in glycogenesis? What do you think? We just had lunch, we got all this glucose floating around. Are we in a working or resting state when we're entering glycogenesis? Because we're taking glycogen, so here's glycogen, or glycogenesis. Glucose supplies are exceeding the demand for ATP. So we take those glucose units that are simple sugars and we store them in long chains called glycogen. So when would ATP stores exceed the demand for ATP in the body? When we're working or resting? Yeah, when you're hanging out and resting, right? So you bring in some food, blood sugar is high, you don't need any more ATP, we're going to store it as glycogen. And where this occurs is in the liver and muscle cells. The liver and muscle cells have the enzyme, so, and kidney, well, we'll talk about this in a minute. But anyway, liver and muscle is where we store this glycogen, also in the kidney and the intestines, but we don't have to worry about that right now. Where we store it is liver and muscle. But we have a limited number of stores. So the more we work our muscles, the more glycogen stores we create. And that's a good thing, because if we're taking excess glucose and storing it as glycogen, that's not fat, right? Because the other thing we're going to study, excess glucose gets stored as fat. So we're storing it as glycogen in liver and muscle. Then when blood sugar levels go down and we need sugar to make ATP and we're not eating actively, then we take that glycogen, and these cells, the liver, the kidney, and the intestines, can reverse this reaction and break down glycogen to make glucose. Because glucose is what needs to enter into the glycolysis reaction, right? So it has to be glucose. So glycogenesis, I'm going to ask you on the quiz examples of when this would be occurring. When you're hanging out, right? You're in a resting state. Glycogenolysis would be when you're in a working state and blood sugar levels are low. We need to break down glycogen. And then once all the glycogen levels, once all the glycogen stores are used up, then where do we go? What? Well, depending, if we're still in a working state and we've used our glycogen stores, then we can, what? Yeah, then we can go to fat stores, yeah. Okay, so gluconeogenesis is what people rely on in a low-carb diet. So make sure you write that down here on this slide. Low-carb or zero-carb diets are trying to get their body to enter into gluconeogenesis. And the root word or the key word to look in here is neo. You've heard the word neo-Nazi before, maybe in the media or in history books. Neo means are like the new Nazis. You know, all the old Nazis are passed away. That was a long time ago. But neo-Nazis are that term used for people that are new Nazis, that are horrible people. But neo means new, okay? So new. So making new glucose from non-carbohydrate sources. So we're going to fat or protein to get glucose. So when it says non-carbohydrate sources, maybe put in parentheses in your notes, fat or protein. We're going to use fat or protein to make sugar. So this occurs in the liver. So if you have a shot liver from a lifetime of alcoholism, malnutrition is a #1 diagnosis that those patients come in with. They get what we call a banana bag. It's just a bag full of vitamins and nutrients to get their energy and their metabolism going, because they're usually very thin because of dysfunctional liver that can't do all this nutrient interconversion. Okay, so the glucose can be formed from glycerol and amino acids. Glycerol comes from fat, amino acids come from protein. So if glucose levels stop, we can go after that. And that's good because we don't want to get hypoglycemia. Hypoglycemia can lead to, well, for those of you that have hypoglycemia, I get it if I eat something really sugary for breakfast and I get a big insulin surge from that, then you get a big insulin washback that takes it out of your blood, and then your blood sugar drops as a result of that. I get shaky, sweaty, kind of nervous, not able to think very clearly. It's a bad feeling, and I try to take care of it when I start to feel it creeping up. Or early signs of that is fatigue and crabbiness. And for those of you with kids, how many times you pick up your kids at 3 o'clock and they're just rotten in the back seat and crabby, right? Or yourself even maybe, or your kids, you're talking about your kids?
Okay, maybe all of us.
Right.
I mean, I have 5 also.
You have 5 at home? Yeah. Yeah, it's so easy to slip into that and not even realize it. I found that when I was home with my kids, I was trying to lose weight after having babies, so I would eat lunch and then I'd have like a snack about 3, something light, and then, you know, wait for dinner. And I would be hungry for when dinner was coming. I'm waiting for my husband to come home so we can eat dinner. And my blood sugar would crash, and he would come in the door and I'd be like, rah, just hangry. I'm like, this is a bad mix. And he would come home hangry too. So it's like, why are we so crabby and hate each other right before dinner? And then after dinner, oh, that doesn't bother me so much anymore. And oh, I'm sorry I said that. So I found that a snack, you know, a better snack around 3 and a caffeinated source of energy helped me, because I had 4 kids at home at the time, and yeah. Anyway, So our brain prefers glucose for energy, and our blood cells do as well. So brain and blood cells prefer glucose for energy. So some people can't tolerate, like if you're a low blood sugar person like me, I tend to be hypoglycemic, I can't tolerate a ketogenic diet. I've tried it, and I've had blood sugar crashes during it that I can't do it. I even had it when I was teaching advanced A&P lab. I had a blood sugar crash. I was trying a ketogenic diet because my husband does really well on it, and I want to support him and, you know, go on it together. But oh my goodness, I was like, I couldn't talk. I couldn't like form the words, and I got shaky and sweaty, and I had to go eat something very sugary to get my levels up. So some people can't tolerate it, but some can. So the brain can switch to something called ketosis, or using keto acids for energy, which we'll talk about. Yes, ketones is another word. Mm-hmm. Yeah, right. Mm-hmm. Yeah. Yep. Yeah, well, and I think some women, and this is probably what you and I share, is that we don't have great glucagon secretion. It's not insulin. Insulin lowers blood sugar. Glucagon raises blood sugar. It promotes the breakdown of glycogen. And if you have low glucagon secretion just because that's the way you are, then your body doesn't release that glucose in between at times when there's no glucose available. And that's what that happens to me. So I do well with just a healthy carb diet and just watching when I eat and, you know, exercising. But, all right, so let's look at then, yes.
So does glycogenesis protect against damaging effects of low blood glucose levels? So it's
Mm-hmm.
saying, I don't understand, is it saying that you should eat protein and fat, not I don't understand.
It means that if sugar is not present, like you're in a starvation mode, right? We need to break fat and protein down to release glucose. Yeah, yeah. So that's how children like in Africa that have the swollen bellies and are very thin, they're still walking around and alive because their body is using fat and muscle. That's why they're so thin in their arms, right? They have no fat or muscle. Their body is using that to keep the brain going, right? Because the brain is the boss. If the brain dies, the rest of the body dies. So yeah. And it doesn't mean it does it well, right? And the examples that we were just talking about, we feel horrible in those situations, but over time the body does adjust, so we wouldn't die, but we would be pretty miserable for a while until our body was used to not having carbs. And it takes sometimes, some people it takes a month to get there, some takes 2 weeks. I wasn't willing to wait that long because it was affecting my quality of life, and it sounds like it was affecting your quality of life too. So, and the quality of the lives of the others in your home. So, yeah, yeah. Mm-hmm. Right, yeah, yep, yep. So, okay, so the big thing that I want you to focus on here is the liver is what interconverts glucose, proteins, and fats. We can go all different directions. If you look at what's happening here, fatty acids are processed by the liver, converted to ketone bodies, and the body uses ketone bodies instead of glucose. The brain can use ketone bodies instead of glucose for energy. And that's where people that do well on ketosis can lose a lot of weight. Like my husband lost 40 pounds on it with hardly even trying, and he was eating bacon, eggs, and cheese, and just having a great old time. But oh my gosh, I could not eat that. My stomach too was kind of sensitive. I know we had like burgers on the grill, you know, with no bread, and it was just so heavy that I just, I didn't feel it. It wasn't a diet for me. It's not a diet for everybody, but some people swear by it, and I've had students swear by it, but ironically, they've all been male, and I don't know if it's something related to women and their guts. Women gut health is not good because of estrogen. The estrogen is hard on the gut, and women, if you don't have to volunteer this, but people have maybe noticed how their bowel habits change around their period. And when the period's coming or the middle of the period, bowel habits change, appetites change. So our guts are a little more sensitive than men are. Okay, so The main organ for nutrient interconversion is the liver. The liver can use, like I say, fatty acids, glycogen for energy. And like I said, muscles can also, for energy, use fatty acids. They actually prefer fatty acids. So the good thing about that is how do you get your muscles to want to break down fat? Sitting in a chair playing video games? Right, get your muscles moving, right? That's the really an effective way to lose weight, is to get your muscles moving. If you get your muscles moving, they prefer fatty acids as a source. And that's really good for us. And we know that you don't have to get your muscles moving for an hour on a boring treadmill or a bike. Just lifting weights gets your muscles moving, right? And that causes them to bring in fatty acids, break down fat for energy. So a lot of people will tell you that, 15 minutes of intense exercise where you're using your muscles really strong has the same effects as an hour of aerobic activity. So do any of us have an excuse for not to get a little bit of exercise? Do we have 15 minutes in our day? Probably. Does it feel good to do high intensity exercise for 15 minutes? No, it feels horrible, especially in the first minute or two when you're in the lactic acid, because the Krebs cycle, electron transport chain takes time to kick in. Those enzymes take a while to do their job. So we always feel short of breath. We always feel the burn in the first few minutes of exercise because we're not in that high ATP producing level of exercise yet. And you start slow and work your way up. Okay, so related to sugars then, you have 4 G words to differentiate. Glycolysis, we talked about. That's just the first step of cellular respiration, so don't let that G word throw you off. The word glycogen is not in there, right? So this has nothing to do with glycogen, it has to do with glucose. Glyco means glucose. So converting glucose to pyruvic acid, we call that glycolysis. We've talked about that already. Glycogenesis, there you see glycogen and the word genesis, so we're making glycogen. And again, when would we be doing that? Working or resting? Resting, yes. Glycogenolysis, we need to break that down to release glucose into the blood. When are we going to be doing that? In a working state. And then gluconeogenesis, when are we going to be doing that? When would we be needing to go to fat or muscle? Starvation is one example. Another example is we've just been talking about zero carbohydrate diets. Yeah, zero carbohydrate diets. Or what happens if I have no insulin? What if I'm a type 1 diabetic and I have no insulin to let the glucose in my blood into my cells? What are my cells going to use instead? Fat or protein. So early signs of a newly diagnosed diabetic is weight loss because their body is breaking down fat and muscle because there's no ability to use the sugar from their meals because there's no insulin around. Okay, the next topic then is fat oxidation. Let's take a short break and we'll come back and talk about that. All right, talking about lipid oxidation then. So when we talk about lipid oxidation, we're talking about burning fat. So burning fat, that's the fancy word for lipid oxidation. So if we look at triglycerides, this is body fat. Make sure you write that down. Body fats are triglycerides. That's what we call that white, shiny, rubbery stuff we see on chicken, right? Those are triglycerides, body fat. They're solid at room temperature. That's what you see in the white in your burger, right? A really easy way to reduce the fat from your tacos or anything you're adding hamburger to is to do what? Some of you know this already. You fry your burger in the pan, you drain off the grease. What's the next step? You can take, and I tell my daughter to do it, my oldest daughter is big into healthy cooking, and she buys the extra lean burger, which is like $5 a pound versus the cheaper stuff, which is $3 a pound. You can convert it to that by doing this simple step. Do you know what it is? No, that would help. Rinse it with hot water. Rinse it with hot water. And that'll run all the fat off of your burger and turn it into a lean burger. And how easy is that, right? Except, be careful, because I made a boatload of burger one time because we were going out of town and I was making a bunch of stuff for tacos. And when you run it down, make sure you throw some dish soap down there, because when the water cools in your piping system in the basement, what happens to all that hamburger fat? It turns into a solid. So at 2 in the morning, all of a sudden we had water bubbling up through the sewer pipe in our basement, and it was really bad. So we called some guy in the middle of the night. Great people. Father and son team comes in at 2 in the morning to our house. We'll take care of it right now. He answered the phone at like 1 in the morning. I was just going to leave a message, you know. And he came. So he's in there and he's scooping all this nasty stuff from her pipe out, and he brings it up to his face and said, "Smells like burger." I'm like, oh my gosh. And then my husband's like, "Who was cooking that much burger?" Me. So, yeah, so be careful. Dish soap will break down the fat molecules, right? All right, so back to this. So lipid oxidation. So we take triglycerides with the help of this enzyme, lipase, breaks fat down into its 2 component parts, glycerol and fatty acids. This is what our body can use as a fuel. They can't use triglycerides, too big of a molecule. But glycerol and fatty acids can be used by a fuel for our cells, so we need to break it down with the help of lipase. And this very important enzyme, a majority of it comes from the pancreas. So if someone has pancreatic cancer, what is their problem? They can't break down fats. They can't break down fats in the diet. And what happens when those fatty things enter into the colon and they're not broken down? It causes cramping and abnormal bowel movements, and it's a real problem. So breaking down fats, and they can't absorb fats. So if they're eating fatty things, what do you notice about people that are dying of pancreatic cancer? When you see them on TV, you know, the actors and actresses, they're very thin. They lose weight rapidly because they can't break down fats in their diet to release the glycerol and fatty acids to enter their cells and be used for a fuel. They end up just passing right through. Okay, so glycerol is broken down by glycolysis into pyruvic acid. That's great. That's what we need for the Krebs cycle, right? No problem. We're on our way to using that energy. And fatty acids also can enter into the Krebs cycle by being converted to acetyl coenzyme A. So both of these, glycerol and fatty acids, are converted to acetyl coenzyme A, which we know fuels the citric acid cycle or the Krebs cycle. So we can use fats to make ATP. And again, fatty acids are preferred by what? What cells prefer fatty acids, did we say? Yes, muscle cells prefer fatty acids. So lipid oxidation means breaking down fat. So what type of state are we in when we're in lipid oxidation? Working or resting? In a working, yeah. Burning fat, right? That's when we're moving and using this source if there's no sugar available. Or if we're working our muscles and there is sugar available, we're still going to break down some fat. And you don't have to be killing yourself to break down fat. There's something called the fat burning zone that we enter into, and that's the healthy type of exercise where your heart rate is a little bit elevated, but you're not huffing and puffing and struggling. Like when people are, you know, doing intense exercise for long periods of time, that actually promotes inflammation, breaks down the body. It's hard on the heart. People that are elite runners that run fast, long, hard distances actually have calcifications in their heart muscle because stress hormone is chronically being produced and it does damage to the heart. So we know that, you know, being really fast and intense with exercise for long periods of time is not good for us. Okay, lipogenesis. So what do we know about genesis? It means to make or create. So we're making fat. So this occurs in what type of state? Obviously the resting state, right? When we were sitting back curled up on the couch watching the Grammys last night, right? Was anybody doing that? Anybody watch the Grammys? It was pretty good. There were some weird performances, I thought, too, a little strange type of music. I'm just getting old, maybe. But this is in the resting state. So when ATP and glucose levels are high, we filled our glycogen stores. There's no more need for this excess glucose. We're going to store it as fat. So glucose, this is a key thing to remember. Glucose is easily converted to fat. So when we have diets high in sugar, that is an easy process to be stored as fat. So if you're trying to decide what you're going to have to eat for lunch before you go on to class, or what you're going to have for breakfast before you go to class, having a sugary breakfast, as you're sitting in class, your brain is using energy, so it's good to fuel that. The glucose is good for that. But a lot of excess glucose, sugary breakfasts, like junky cereals that are in abundance on the shelves, which my kids like, or white bread toast and bagels are not good choices when you're sitting a lot, because it gets converted to fat very easily. Where we know that with the help of insulin, it leaves our bloodstream and enters our cells, right? But we know that proteins and healthy fats are good choices for fuel because they don't pull insulin out and cause these high insulin surges and crashes, and they keep your blood sugar stable. So they keep you feeling fuller longer. So fats and proteins, healthy fats and proteins, are preferred sources of fuels with a little bit of carbohydrate mixed in. So if you're choosing something for breakfast, whole wheat toast that has complex carbohydrates in it with some peanut butter on the top would be a great thing for breakfast. It's not expensive. People say, oh, healthy eating is expensive. Not really. I mean, if you look at your bill at Taco Bell or the McDonald's drive-thru, those are expensive. You can cook a lot of food, healthy food, for a lot less if you know how to buy the right things. And we'll talk about that throughout the semester. But whole wheat toast with a big jar of natural peanut butter is not that expensive. It doesn't go bad in your backpack, and it prevents those cravings as you're coming home from class and you see Taco Bell or McDonald's, right? And you're craving some really yummy food on the way home. If you're a younger person, or even if you're not, Taco John's always calls my name when I'm coming home from an evening shift at Gunderson, and I don't go that way. I literally turn a different street so I don't go that way, because those potato olays at 11:30 at night are tasty, but terrible. So anyway, moving on then. So pasta, not a good choice as a fuel because it burns quickly, increases insulin levels, and causes those crashes, and the excess is stored as fat. So if you can add some chicken to your pasta to keep blood sugars high a little longer and keep you full a little longer, that's a preferred thing. So lipolysis, the word here, lysis, tells us that we are doing what to this fat now? Breaking it down. So we're in a resting or working state here. So we're breaking down fat. Again, we talked about fatty acids are preferred by skeletal muscle cells. The liver and cardiac is also a muscle, so that's preferred. So again, if we want cardiac muscle to increase the usage of fatty acids, we got to get our heart beating more, right? If you're sitting in class and your heart is beating, at a resting rate, it's not using a lot of energy. But if you're exercising, your skeletal muscles are moving, your heart is beating faster and stronger because you're exercising, you're burning fat. And again, it doesn't have to be crazy exercise, just enough where you're breathing a little heavier and your heart rate is up. Okay, so if we don't have any sugar and we just are relying on protein and fat as a nutrient source, so we're eating healthy fats and protein, that acetyl coenzyme A that we already said is produced by fatty acid fat breakdown, that can be converted by ketogenesis in the liver. So the liver is in charge of ketogenesis, taking this acetyl coenzyme A and converting it into ketones. And ketones are a source of fuel that the brain can use. But the bad part, byproducts of these ketones, so acetoacetic acid, hydroxybutyric acid, and acetone. Where have you heard acetone before? What's that used for? Nail polish, yeah. So when acetone builds up in the blood, it diffuses across the lung tissue, and people have a breath that is kind of acidic, and people talk about the ketogenic breath. It's not a pleasant smell. It's kind of a sharp smell. And if a person is in diabetic ketoacidosis, where blood sugar is really high, in addition to being in ketogenesis, they have a fruity odor to their breath. People say it smells like juicy fruit gum that exhale because it's acetone mixed with high blood sugar. So, lipid metabolism, this just shows the different directions. So blue is where we're breaking down fat. So here you have stored fat, we have dietary fats, right? So those are triglycerides, that's the bad fats, the omega-6s, right? So that's broken down by lipolysis to glycerol and fatty acids. Fatty acids are burned by beta oxidation, or converted by beta oxidation, to acetyl coenzyme A. Glycerol can enter into glycolysis. And then amino acids too can be used. We'll talk about that next. But the acetyl coenzyme A then is converted to ketone bodies in the liver by ketogenesis. And acetyl coenzyme A, we know, is part of what starts the citric acid cycle, and we get lots of ATP that way. So we can use fat as a source of fuel when sugars are low. But here's another quick thing. Acetyl coenzyme A also is used to make cholesterol, which can be broken down into bile salts. But if we have excess breakdown of cholesterol and body fat, we can end up with bile salts accumulating, and what does that cause? Gallstones and gallbladder attacks. So we have to be careful with excess cholesterol in the diet. That leads to gallstones. Obesity is a #1 risk factor for gallstones. Pregnancy or just recently giving birth is another, because we have high cholesterol during pregnancy and right after birth. That can cause gallbladder attacks, and rapid weight loss can cause gallbladder attacks. So beta oxidation is breaking down fat to fatty acids and then to acetyl coenzyme A. So both of these are breaking down fat. Beta oxidation or lipolysis. Beta oxidation is just taking it a step further, taking lipolysis a step further, and lipogenesis is forming fat. So the last fuel source that we bring in is protein. Protein we find in nuts, eggs, meat, fish, cheese. Those are all good sources of proteins, and certain legumes like beans and quinoa. Have you heard of quinoa before? Some people don't know that's how it's pronounced. I'll write it so you know what it looks like. Have you seen that before on the shelves? So, it's called quinoa, and it's really tasty actually. I've mixed different things in it. It's real easy to make. You can buy it in the grocery store and you just add water and it fluffs up into this really, they're like little round, it's hard to explain. They're like a mixture between a seed and like a rice almost, but they're round. And you put a little olive oil in there or some balsamic dressing with chopped up onions and nuts, and it's very tasty, and it's a really high source of protein. So protein reactions then, what's the organ involved again? The liver, right? The liver. But there's another organ that enters on the scene when we look at protein breakdown, and that is the kidneys. So the take-home message, real life application, that if you are someone who has stage 4 kidney disease and you're on dialysis, do you think you need to watch your protein intake? Definitely, because they have a hard time breaking down protein, and those toxins build up in the blood. And the #1 toxin that is excreted in the urine by the kidney is urea. Yeah, so urea can build up in the blood, and that can be dangerous. So we look at levels of kidney function when people come in with kidney disease. What is going on here? I got to stop those notifications. What? Okay. So 2 reactions you need to know is transamination and oxidative deamination. Either way, we're talking about amino acids. So it just depends on where the products of those reactions are going to. So transamination is where we take that keto acid and that is excreted into the blood. So we're forming keto acids from amino acids. So this is the ketogenesis, right? This is, but we take the amino acid, combine it with a keto acid, and that is modified in the liver, sent to the blood, and serves as a fuel for the citric acid cycle. Oxidative deamination is taking that amino acid that results and converting it to ammonia, then urea, and then excreted to the blood and enters the kidney and down to the urine. So we're creating urea here. And the key thing with this is this ammonia is released as a result of oxidative deamination, but the liver's going to convert that to urea and release carbon dioxide as a waste product. What happens if I have a liver that's shot and I bring in, or I'm breaking down protein, let's say I'm breaking down muscle, so it's a person with alcoholic cirrhosis of the liver, so their liver cells are shot. They can't do this job. Now what? What happens to the ammonia? It builds up in the blood. And when ammonia builds up in the blood, what does that do to pH? Ammonia is a base, so it raises the pH, which also interferes with brain function. And people will come in and act like they have advanced Alzheimer's when they have high ammonia levels. And we have patients that come in, that are found on the floor that have drank themselves into a terrible state, and they have this high ammonia levels. So then we give them this special medicine called Keexolate that causes them to basically kick in their bowels, and their bowels get rid of the excess ammonia. So that's a pleasant experience, right, for that patient who already feels miserable, and now we bring them in and induce some violent diarrhea. And they also are acting a little wacky because of high ammonia levels, right? So is it fun to take care of a patient in that state? No, it's not fun for anybody, right? It's hard on the staff, it's hard on the patient, and that's liver disease. So other liver diseases that are not based on, addiction are what? What do you know about other liver diseases? Hepatitis, have you heard of hepatitis before, right? That's called, there's Hep A, Hep B, Hep C. Hep A is from what? It's spread in the stool. So who gets Hep A? Anybody in here could get Hep A at Taco Bell. When I lived in Madison, when I was in school, somebody didn't wash their hands properly and got Hep A in the taco meat, and a bunch of people were exposed to Hep A at Taco Bell. So Hep A is in stool, and it can be spread, fecal-oral route. Hep B and C is, body fluid exchange, so IV drug use or intercourse, but more blood exchange, so it's more IV drug use. Okay, so when we look at all the sources of food that we eat, proteins, carbohydrates, and fats, proteins are broken down to amino acids, carbs into glucose, can be stored as glycogen, fats are broken down into glycerol and fatty acids, and if those come together, we can form fat. That's body fat, right? So I can bring in fat in my diet via cheese, vegetable oil, and butter. My digestive system will break it down into these things. They'll be absorbed into the blood, and then any excesses will be converted to triglycerides, which is body fat. And again, glucose will be broken, this complex carbohydrates will be broken down into glucose. Excesses will be stored as glycogen. And if we need to make ATP, it's going to enter into the glycolysis, the Krebs cycle, and the electron transport chain to make lots of ATP, releasing carbon dioxide and water. And then proteins are broken down to amino acids, which can be reassembled to make other proteins like muscle or skin and hair proteins, collagen, keratin, or hormones that are proteins like insulin and glucagon. and ammonia is released, but the liver will process that. So again, catabolism is anything that is breaking down substances. So when we break things down, that's catabolism. And when we're creating new things, that's anabolism. So fat formation is anabolism. Glycogen formation, anabolism. Making new proteins on the ribosomes with the help of DNA and messenger RNA, that's anabolism. Protein synthesis is anabolism. So we talked about if we accumulate ketone bodies in the blood, that's called ketosis. And when some people are trying to do that in a low-carb diet and they're really in that fat-burning stage, the body's in ketosis. They've switched away from glucose and they're using ketones. There's urine test strips that people can use to see if they're in ketosis, and people buy them when they're on zero-carb diets to make sure they're in ketosis, because sometimes you can introduce a little bit of carb into the diet and still be in ketosis. So people try to find that right balance of where they can still be burning fat but be able to eat a little bit of carbs. But ketones are acidic, and if they build up in the blood, which means we have high blood sugars, low insulin levels, that's what tips people into this metabolic acidosis. And they end up coming into the ER lethargic, low on protein and fat, so they're losing weight, and they have that fruity breath from acetone with high blood sugar levels. And they're breathing in a rapid, deep manner because they're in an acid state and the body is trying to get rid of carbon dioxide. And that's another concept we'll talk about later in the semester. But carbon dioxide can be converted to carbonic acid in the body, and that can drop pH if we have a buildup of carbon dioxide. No, it happens in a combination of no carbs and high blood sugar and low insulin, yeah. Okay, so that concludes our discussion of metabolism, and I have that crossword puzzle to help you prepare for the test.